Hi everyone. Today again I am on the same MLS tutor platform welcoming you all guys. Let's begin our today topic, synthesis of thyroid hormone. So it is a long topic. I will try my best to cover during a short period. So as we have to talk about the thyroid hormone synthesis, so there is the requirement of iodine, so we need to trap the iodine. So first step is our uptake of iodine or trapping of iodine. So to trap the iodine we need the iodine first of all from our diet or another form that is in our body. Then we need require the sodium potassium ATPase to generate the energy, because we are taking the iodine into the thyroid gland, which is against the concentration gradient, which is 20:1. So we have uptaken the iodine. Now the second step is activation of the iodine. So activation of the iodine is nothing rather than the change of charge on the iodide ion. So we require there S2O2, that is hydrogen peroxide, then other thyroperoxidase enzyme which convert the negative charge of iodide into positive charge of iodide. So second step, our activation of iodine is also completed. Now third step. Third step is thyroglobulin and T3 T4 synthesis. So let's talk about thyroglobulin. Thyroglobulin is nothing rather than a glycoprotein which is present in our body and the thyroid gland. So when there is the requirement of the thyroid hormone in our body, then TSH stimulates the thyroid gland to synthesize the thyroid hormone. And there is the 140 tyrosine residues on the thyroglobulin molecules. So these tyrosine residues capture the iodide ions which is in positive form. So to form the mono iodide tyrosine, there is the attachment of iodine ion at the third position of the thyroglobulin or the tyrosine residues. And to form the diiodotyrosine, there is the attachment of another iodide ions at the fifth position. So to form the diiodotyrosine, there is the attachment of two iodide iodine at the third. So we were on the iodination step, that iodine is binded to the tyrosine residues present on the thyroglobulin molecule. Second step is coupling step. In this step, the monoiodotyrosine and the diiodotyrosine combine with each other to form the triiodotyrosine or the triiodothyronine, that is the T3 hormones. Similarly, two molecules of the diiodotyrosine combined with each other to form a thyroxine, that is the T4. Now the hormones are formed and it is inside the thyroid gland. Now, so our hormones are stored in the thyroid gland. We need to release it, our blood uh, for the what? For the utilization and proper functioning of the body. So, how does it occurs? So when there is the requirement of the thyroid hormone in the body, then TSH hormone stimulates the thyroid gland, and when it is stimulated, then the T3 and T4 are released in the blood, and the T3 and T4 hormones are transported from one organs to another in the form of binding proteins, that are thyrobinding globulins or thyrobinding prealbumin or thyrobinding albumin. So it is in our body. Now where is the requirement? Then there is the step of the deiodinization. So when this step occurred, then the T3 and T4 released from the binded proteins and became free, and those are the active form of the thyroid hormones. And most of the active form of thyroid hormone is the T3, while I am talking to the uh, T3 and T4, but there is the formation of the reverse T3 hormone as well during this process. So our hormone is formed, and where there is the requirement, the body utilizes it, send the different signals, then the hormones goes to the site and changes or perform the metabolic activities or so on. Thank you. Uh, hope you all like my videos.